Okay. Now here's your carboxylic acid functional group. It's this one. Can you see?
Yeah.
Yeah. So when it's written out, it's that line. You've got a carbon. It's attached to double bond to oxygen. And then you've got the alcohol. The alcohol, remember, it's an OH. That's all. So, but then you can spread it out like that and write the H like that. In simple term, we say dash, we put a C. We say, guys, we've got two OH. Now, but I want to make one of the O green. You see the green O? It's actually that green there above. It's the one with the double bond. Because the one attached to the carbon is the double bonded one. You see that?
Yeah.
Yeah. So it can come like this with a COOH. Or, yeah. I think we could. All right. So now here's how it goes. Okay. Let me show you. Huh? Did I miss? Did I pass it? No, that's ketone and aldehyde. Okay, and then let's see. Where are we? Yeah, there we go. There. Can you see? This is carboxylic acid. Carboxylic acid. This is carboxylic acid. So here you've got one carbon. That's the group. And then here, it's the same thing in blue, but now the R tells you are going to have hydrocarbon, methane, ethane, propane, whatsoever. Now, look at this one. I want you to look at this one here. Look at the carbon. You've got one carbon here by the CH3. There is another carbon there. You count the carbon that come from the carboxylic. It's 2. That's why it becomes ethanoate acid. We good, right?
Yeah.
Yeah. That's what I wanted to say. The key, I wanted to tell you this carbon here, that one from the carboxylic, it is also counted. And again, like what I said with the alcohol, when I said it's R-OH, and I said the OH will be found in the boundaries. It will never be sandwiched between the carbon. The same thing with the carboxylic acid. It can never be sandwiched. Let me show you what happened. Let me show you. Let me show you. Because this is where we start. We start here. Alcohol goes with the ether. They both come from this one. They come from H dash O dash H, which is actually what? Which is exactly what you saw last time. H dash OH. It is from the water. Yeah. That's why people who drink alcohol, they want to go relieve themselves in a bathroom many times over. You know? Yeah. Right. So there's 2 H's here. 2 H's. If you replace one of the H with the hydrocarbon, only one, you get an alcohol. So the alcohol will be around the boundaries. But if you replace the other by another hydrocarbon, now the O, it's sandwich. That's now the ether. It's sandwich. Can you see that?
Yeah.
Yeah. So that means you got an example of an alcohol here. You see that one there. So you've got that O and the H. If I were to remove one H there, in its place I put CH, let's say, let me say CH2 and then CH3. you can see right in the middle, you've got the O. That's the ether. That's how we know it. So it goes together. So these partners, the first one is around the boundary. The second partner gets to be sandwiched in. All right, then the next thing here, here's another one. Here's the other one. You're doing the aldehyde and a ketone, the carbonyl. This one here. They give you a functional group, which is what?
We don't.
Huh?
So?
Yes.
So we don't do this one. So.
Eh?
Oh wait. We do alkyl.
Alkyl. Yeah. Don't worry. I'm passing through. You go find. Okay. If you did it, be sure.
Okay.
Yeah. So with this one, this is what you have. The functional group. It's more like this. It's a C double bond, and then one side it has the H, the other side it has another H. They all have two H's, like this one of water. There were two H. You replace one H with a hydrocarbon, another H, then you get the two partners. Now this one, when you put a hydrocarbon here and H here, you call it an aldehyde, which is this one: aldehyde, methanol, ethanol, propanol. But if you go replace the other one, you see in the middle you've got a CO. You see, so I might have something like this, say CH3, and then C followed by the O, and then maybe I might have CH2 and then CH3. You see, then I say, oh, this one has been sandwiched. It must be a partner of an aldehyde. But if you replace only one R, the aldehyde is in the boundary. This is boundary, this is sandwich. So I was saying that to come here to this one, carboxylic acids. Because with the carboxylic acid, you've got carboxylic acid and the ester. So when you look at that one, there's basically another H here. So there's two H's, that red and that one, but they don't show you. So when you replace that one, that stuff gets to be in the boundary. The bluish part gets to be in the bound. That's carboxylic acid. Now, when you go do this one now you've got something that's being boundaried, but you'll be using alcohol and the carboxylic acid. It gives you now the ester. Do you see now? Yesterday they asked us to show them the functional group. We had to go something like that and something around that one there. So that's it. So you've got 3 pairs, which means 6. In each pair, one is a boundary, one is sandwich. One boundary, one sandwich. One boundary, one sandwich. You see? Yeah. Yeah. So now let's okay, yeah, then let's just do this one here. Yeah, if you find out that you're doing the other one, and then we'll do. So now the carboxylic acid. Carboxylic acid, which means we are simply saying we've got that. It's a C double bonded with an O, and then we've got the O and the H. All right, like I said, it's basically there are 2 H's. This side we can put the R, or we can simplify it again. We say that one can come in this manner as C double bond with O, and then they just write the OH strictly like that. Or they can write it as R, and they can write it as C, CO, and then O, OH. I'm trying to show you the green O is the one that is double bonded, because it's the one that's sticking to the carbon. So they'll give, normally they give this one, and then sometimes they draw it like this or like that. You're like, oh, what's going on? So now in place of the R, I can use C, 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 C. Then I can go up, down, left, up, down, up, down, up. Then I can go down, meaning, and put that functional group, meaning I must attach it to a carbon, but the carbon must be attached to O, double bond O, and then it must be attached to the OH, or rather, I can just write it as O dash, and then like that. It doesn't matter. Good.
Yeah.
Then we say, all right, we need to choose the longest chain, including the functional group, the yellow. Our option is this one. That's the first one. Another one is this one.
Yeah.
You got it?
Yeah.
Yeah. But the yellow carbon is counted. Let's start with the one that looks like a 7 that goes like that. Let's count. We've got 1, 2, 3, 4, 5 carbon. Coming from the other side, 1, 2, 3, 4, 5. It's a tie. Can you see that?
Yeah.
Yeah. So then let's say we choose, we say, okay, let's go with this one, the normal one. We go with this one. We're going with that one there. So we're going with that one there. And then we must name, we need to start naming it. It's 1. It's 2. It's 3. It's 4. Then it's 5. 5 is pent. So it's going to be pent. And then we finish the name with the anoic. Anoic. Pentanoic.
Yeah.
Well, we can just write acid. Then this one in white, there are your branches. There's only 3, MEP, prop. So it's a prop, YLE, propyl. But it's in address number 2. So it's 2 dash. So that means the name, I need to take the parent name, put it here, and then put the branch, meaning 2 dash prop So that will be the whole name, meaning 2-propyl pentanoic acid. Do you see that?
Yeah.
Yeah. You're not going to have the dianoic. You're not going to have double of this one. You're not going to have them. Impossible. Yeah. You don't have them. You don't have double of these ones here. So what's going to happen is going to be something like this. You got branches and so forth. Let's try if I can have double branches. Let's see. Let's say we've got 1, 2, 3, 4, and then 5, and then 6, and then 7, 8. Let's go 9. Then I've got, let's come here. We go 1, we got double bond, and then I go put the OH there. Then let's have a carbon there. Yeah, there we go. Now we want the longest chains that include this guy. Well, it's pretty obvious. You have to go this route. Am I correct?
Yes, sir.
Yeah. And then when we name, we're starting from here. It's going to be number 1, number 2, number 3, number 4, number 5, number 6, number 7. 7, it's hept. So it's going to be hept. Am I right?
Yeah.
Yeah.
7 is hept.
So it's going to be heptanoic. Heptanoic acid. All right. And then we've got a branch. That one is in location. Oh, no. I missed that. I missed to count that one. Can you see the yellow one?
Yeah.
Yeah. It's supposed to be 1 here. Everything must be 8. Okay. Just fix it. The numbering, it must be 8. So it's octa. It's going to be octanoic acid.
Okay.
Yeah, oct it's 8, so it's gonna be octa. Oh, all right, so let's remove that one there. It's gonna be octanoic acid. Octanoic acid. Octanoic acid.
Yeah.
Now, let's look at the branch. This one is remember, this is now location number 2. Location number 2. So it's gonna be 2 dash meth. It's 1. It's a branch, YL, methyl. And then also here, we've got the branch here. It's 2, ME ethyl. It's gonna be FYL, ethyl, but location also number 2. Then we start with the branches. We put them in alphabetical order. The E comes first. So that means we're having 2 dash ethyl, 2 dash ethyl dash, we're going for number 2, 2 dash meth, YLE, methyl, and then we need to put that name, the octanoic acid.
Yeah.
Aha. Is it making sense now?
Yes, sir.
Yeah. So this one,
Yeah.
you know, it's in the boundaries, because what I've realized, they gave them all the functional groups that are on the boundaries. No. Yeah, the one on the boundaries, all of them, and one sandwich, the ketone. But they did not give them the ether. I wonder why they did not give them the ether. All right, for now, let's say the naming